Mangoes are one of the most loved fruits around the world, but have you ever wondered how they are grown and produced on a large scale? Australian farmers have been using cutting-edge technology to grow tons of mangoes every year. If you're curious about how they are doing it, then you're at the right place. Welcome to another incredible agriculture video where we show the future of farming now. In today's video, we will reveal Australian farmers' secret of producing mangoes on a larger scale. On the world scale, the Australian mango industry is relatively insignificant. However, production has increased over the past decade, and it is forecast that domestic production will double within 10 years, making it one of the main domestic horticultural crops. AAG 2006. Mangoes grow best in climates that have low rainfall and low relative humidity at flowering, fruit set, and harvesting, and that are warm to hot during fruiting. However, mangoes will tolerate a wide range of climates from warm temperate to tropical. With these climate requirements, mangoes are grown predominantly in northern Australia. Queensland is the major producing state, accounting for 70% of domestic production by volume. The Northern Territory is also a major mango producer, accounting for 20% of production. Let's discuss what tech has changed in the mango industry in the last 10 years and speculate on coming changes. Irrigation, a technology that has made a huge impact on mango crop management in the last decade, has been in irrigation control. Irrigation automation has been made possible by radio telemetry and smart sensing precision technology. For example, soil moisture probes and bore level monitoring devices, resulting in increased efficiency through the reduction of inputs like fertilizers, fuel, and labor. This has allowed smarter and more cost-effective farming, especially important with price pressures and labor shortages. The technology also helps to protect the environment, as fertilizer applications are not lost through the soil profile through overwatering. The labor invested in manual tap turnover can be redirected to focus on maintaining irrigation infrastructure and ensuring each tree gets watered. It also assists in watering during the night and on weekends when staff may be unavailable. Bore-level monitoring devices ensure bores are protected by measuring drawdowns at regular intervals and triggering an alarm if there is an issue. This helps irrigation scheduling, protects the assets, and assists in the sustainable use of the water source. Soil moisture probes are now much more reliable than they were 10 years ago, and the software for a visual translation of where the applied water ends up and recommended watering volumes is now much more user-friendly. There are also several providers, which is a sign of the maturation of the technology. Handheld near-infrared spectroscopy, NIRS. It has been interesting to watch this technology evolve. NIRS enables non-destructive estimation of the dry matter content of mango fruit. Dry matter content is an index of starch and sugar content in the fruit, which in turn is related to the eating quality of the ripened fruit, as all starch converts to sugar. The measurement has proven to be useful in judging both harvest maturity and eating quality. Australian-developed technology became available on pack lines 2 decades ago, but it was not adopted in the Australian mango industry. Sorting after harvest effectively created an inferior class of fruit of reduced value. One Harvest, a company in Australia, championed the use of handheld NIRS as it became available, with measurement of Calypso fruit on tree. This information is used in the decision to pick, with a delay in harvest allowing an increase in fruit dry matter content. Today, the technology has spread through the mango value chain. Large farms have their own units. Small farms are served by the Australian Mango Industry Association, also known as AMIA. Industry development officers and marketing groups and retailers have units. Retailer product specifications have been amended to specify dry matter requirements, varying by cultivar. As for any technology, handheld NIRS continues to improve, with a recent major advancement being the introduction of artificial neural network models in the operation of the units, which are proving to be much more robust in use than the prior method. Development from flower to harvest-ready fruit is a function of time and temperature. Heat units were introduced to the Australian mango industry by Jan Dixbalis in the 1990s, so the general concept is not new. However, the temperature can vary between blocks across a farm, depending on geography, so the use of a temperature record from a faraway Bureau of Meteorology, or BULM station for short, or a single station on the farm limited the potential of the technique. Field sensors with data loggers became available, but the job of downloading and transferring data became an extra task for the farm manager. In recent years, low-field sensors with LoRa, long-range radio, communication have become available. A web app at www.fruitmaps.info provides an automated estimation of harvest dates from user-entered flowering dates from 10-year history data and the current season temperature data of a local LoRa-enabled sensor. The Sensor Host sensors, made in Rockhampton, feature a battery life of over 2 years and a range of several kilometers. Machine vision flower and fruit load estimation. Estimation of the timing of a flowering event is fundamental to the estimation of harvest timing using heat units. The level of flowering is also useful in the first estimation of the potential fruit load for the season. The actual fruit load will reflect pollination conditions and level of fruit drop, with a reasonably reliable estimate possible at the stone hardening stage, approximately 5+ weeks before harvest. Measurements of flowering and fruit load can be done manually, but this requires a consistent operator. Machine vision can be used to count mango panicles and to count fruit load from stone hardening onwards. One such system from the Multiscale Research Project is being developed as a product by Freelance Robotics. These systems have the potential to include machine vision measurements of the size of fruit on a tree to forecast fruit size distribution at harvest. Harvesting. A part of the mango madness of the harvest season is in the management of a large number of casual harvest workers for the short harvest period. As the years passed, local labor disappeared, and the industry has become reliant on overseas labor. At first, this was based on backpackers, with nationalities drifting over the years, and then the Timorese and Pacific Islander labor schemes, accelerated by the COVID border closures. Mechanization is needed to reduce harvest labor, with the same technologies that allowed mechanization of the packhouse over the last decades relevant to harvest. Mango fruits spurt an acidic sap when the stalk is detached. In the rest of the world, mango fruit is harvested with the stalk on, then transported to the packhouse for deer stalking. The Australian mango industry has moved to snap the fruit from the panicle at harvest, using harvest aids in the orchard that wash the fruit to remove the acidic sap and convey fruit into field bins. Initial versions of the harvest aids were tractor-towed, but now most units are self-propelled. The next step in the process of mechanizing harvest is to add mechanical arms to automate the picking of fruit from the tree to the harvest aid. This is a technology to watch in the coming years. Predicting the optimum time and estimated yield for mango harvest. Timing is everything to Australian mango farmers. They regularly face the challenge of deciding when to harvest their fruit, which affects how many fruit pickers and packers they need, and when to market their fruit. Using data to create an accurate way of estimating crop yield and the best time to harvest. Researchers from Central Queensland University's Institute for Future Farming Systems worked with the ARDC to develop an innovative product called Fruit Maps, which translates data from sensors located in mango farms onto maps and into tables. The data includes an array of information, including temperature, fruit assessment, and processed tree images to help farmers decide when to harvest their mangoes. The new product enables growers to pinpoint the best time to pick their crops. The data-driven system has been widely adopted within Queensland's mango industry, providing farmers with a more accurate, efficient, and cost-effective way of managing their mango production. Farmers now can better estimate the size of their crops and the best time for harvesting, allowing them to employ the optimal number of pickers and packers at the optimal time. Consumers also benefit from having better mangoes. Farm performance has increased by more than 40% for some mango farmers. The project's success laid the foundation for further improvements for mango farmers. The research team has now developed an automatic fruit harvester based on the data services and technology running the Fruit Maps system. The prototype takes only 5 seconds to harvest a mango. Fruit growers in Queensland have described the new data-driven technology as a game changer. Harvesting mangoes used to be a time-consuming and labor-intensive process, But now farmers use machines that can do the job in a fraction of the time. These machines use advanced sensors and algorithms to determine the ripeness of the mangoes and pick them at the right time. Once the mangoes are harvested, they are transported to a processing facility where they are sorted, washed, and packaged. The facility also uses technology to ensure that the mangoes are of the highest quality. For example, they use cameras to detect any blemishes or defects in the fruit and remove them before the mangoes are packaged. Thanks to these cutting-edge technologies, Australian farmers can produce tons of mangoes every year, which are then exported to markets around the world. So next time you enjoy a delicious mango, remember the cutting-edge technology that made it possible. Don't forget to like this video, subscribe to our channel, and hit the bell icon. Like always, we want to know what you are thinking. Technology has definitely impacted farms in reducing labor costs. But do the capital constraints they create hinder growth potential? Comment and let us know below. Thanks for watching another incredible agriculture video. We hope you enjoyed.